So yeah, my name is Soren. I'm a game programmer. I would say hobbyist first, then a professional second, but it changes depending on time of day. I thought it would be maybe fun to just do a little bit of a live demo and just put together something fun, and then some of the area effects in games were on my mind, so I figured why not? Let's put together some explosions in a test area and see how far we can go. I have a to-do list for this presentation. I want to implement modular area effects from scratch in Unity, and I want to do this, if possible, with very short pieces of code. So I want most of my scripts to be, like fit on the screen and easy to just internalize. And I think I managed to pull this off. We'll see as I go through my material. Secondly, I want to show a neat way to make those scripts talk together. Well, if you want to blow things up in a game, some systems will necessarily have to exchange some level of information. And this is like a very typical problem for everyone from beginners to advanced programmers writing a game. How do we communicate between different areas in code? I think I have a way that's maybe slightly less popular than some others, and could be better. Of singletons. And finally, if I manage, I want to make a case for creative use of area effects. I want to give a few examples, at least, of like, doing AOE that's not necessarily literally something blowing up. And I think you can get quite creative and can achieve quite a lot of things with this little piece of code that we're going to be putting together today in this presentation. It's going to be pretty technical. I will also go pretty fast through some of the code, but everything that I will be showing today is already uploaded to a public GitHub. It's under MIT, so everyone can just go and grab it and go at their own pace. And also, I am in the Discord, and my DMs are open. So if there are ever any questions or some things I have to gloss over in the presentation, feel free to just message me if you're interested in playing around with it. Hopefully, it becomes useful to someone. Two pieces of materials that I wanted to acknowledge before going into the demo. There is this GDC talk, Map for Game Programmers. It's about cameras. I think it inspired the way I've done camera shakes for this demo. So I wanted to share it. It covers the topic much better than I ever could. So highly recommend anyone interested in checking this out. And then the other one is a classic, The Art of Screen Shake. It's from Jan Willem, used to be from Vlambeer, the makers of Nuclear Throne and a bunch of other great games. They know a thing or two about making games, action games, feel very actiony. And I think it inspired a lot of the stuff that I generally do in this demo and beyond. So I just wanted to have it in my presentation. I hope maybe I will drop the PowerPoint in slides somewhere so people can grab the links. I'll figure something out after the presentation. Okay, I have a lot of material, so I'm not going to delay any further, and I'm going to just close the PowerPoint, my favorite program, and instead open up Unity. I have 7 sections, and we'll go from very basic, from no code at all, to hopefully something cool, as in we will blow up some props. So first things first, in section number 1, I think I want to tackle 2 things. Number 1 is how to approach solving a difficult gameplay problem, like how to start writing code, because there's, if I want to have a cool explosion, there's quite a lot of things that need to happen. And this can be overwhelming and block anyone from actually starting doing anything. So we need to simplify first. And I think a good way to think about something like an explosion is to just think of it like a sphere. Maybe this is just me watching Dragon Ball as a kid, with like all the like a lot of the explosions were literally like spheres of white light. But I think it's a good model. A sphere has a position in the world. It has a certain volume or a radius, which we can use to sort of calculate who we affect with an explosion. And well, we can make it tangible. It can literally be a ball of light, or we can change the sphere into smoke a little bit later, or whatever else. It's just a nice model for something to start with. So what I've done in section number 1, actually the zoom is covering my controls, which is pretty fun. Is there a way to make it go away? Well, I'm going to do this for a second. All right. So, oh, that's the wrong thing. One sec. That's better. So this is my test scene, a target dummy on a gray checkered floor. And whenever I click somewhere, here's our sphere. So I did exactly as I said. Our explosion right now is literally spawning a sphere anywhere I click. And now I will go through how this was achieved and how this sort of informs, solving this problem sort of informed, like some other things we had to do in order to have some kind of a structure going. So the script number 1 I will go through is our, this is the place that controls everything else. It's called game, very originally. And this script is essentially, figure out everything at the entry point and then go from there. So one thing that we need to solve is something like anyone who's done any Unity work, especially in top-down, has seen this piece of code, like grabbing an array from a camera and then figuring out where the player actually clicks in the game. So I'm not going to go too much into that. The interesting part is the communication. I promised to showcase a way to communicate scripts together. So after I calculate wherever I actually clicked in the world, I don't really I don't really call any scripts. I don't run any code that's related to any explosions. The only thing I do is I say send message, and then I pack my information into the message. And I have no idea where it went. So on one end, we figured out one problem. We know where we clicked, and then we told the world about the click. And then on the other end, I promised short scripts. So here's the spawner that is responsible for making our explosions appear on screen. It has 3 things it can do, or I guess this is a piece of data. So it knows a game object that represents an explosion. It knows what to do on mouse click, which is, instantiate my game object. And then the third and the interesting part is it subscribes or expects mouse clicks to happen, and then provides its on mouse click implementation to handle this kind of an event. And the way those 2 are connected is through something called an event bus. So if you look at the implementations of game and spawner, I created 2 abstractions that will be used throughout the demo. The big thing is the big object. It's a gameplay object. It's a little bit like a game object with our own logic added to it. And then any component is a gameplay component. Similarly, it's a component that has some additional logic that we have. And if we look at the gameplay object here, it does allow us to send messages through something called an event handler, which it initializes. And if I go to what this event handler is, it's essentially a script that is capable of letting people subscribe and to subscribe to messages and then raise those messages to any subscribers. I'm not going to go too deep into what each specific line of code does. I wanted to highlight one interesting thing that's because I'm sure if anyone has done any programming, you've seen delegates, you've seen events. This is .NET bread and butter. One interesting thing about this particular approach is that this is entirely message type driven. So I am not thinking about what the function is. I'm not thinking about who the person performing the function is or the script. The only thing that is important whenever when subscribing and raising a message is the actual message type, which you can see whenever I click. I say send message. I go into my list of messages, and this is the pure data. So the mouse click is as simple as can be, and I can send it to the world. It goes into the event bus, and this piece of code resolves, like, and understands what to do with this piece of data, can use its type to raise it to everyone interested. And then one of those interested components is, I believe this guy receives interesting piece of information and shows a sphere on the screen. So I click, we do some math, I send out a click information, and then the component receives the information and shows up a sphere wherever the click happened. And finally, just to drive the point home, if we look at how the components are structured, the game and the AOE spawner just exist as two separate things. They don't actually reference each other in any way. They don't have, like, there's no traditional drag me into one thing into the other. There is no singleton. There is simply an event bus that does this behind the scenes. And then we can have write as many components as we need and subscribe to as many types of messages as we want. This has one nice advantage over some other ways of doing that, and that is this code is easy to change. You'll see as I go through my examples that it's very easy to add new things without writing any more code related to communication. I know I've been talking about this for quite a while now, but I promise you we're done. After we're done with this, we're just going to focus on what information we send and then what gameplay we get out of this information. So that's the way that I decided to use for the communication throughout the demo. Okay, let's leave the architecture conversation alone, I hope, for the rest of the demo, and go to section number 2. In section number 2, I wanted to start slow, but I still wanted to do something interactive. So we have our model of an explosion, which is a sphere that just sort of sits there infinitely. I think to bring it a little bit closer to something that is, any kind of an effect in a game, I think it should, it should have a certain type of a duration. So this is exactly what I've done. If I click play here, start clicking around, we now still get the sphere, but if you're using your imagination hard enough, it now, something like some spell is happening in there and then it's gone. And I've done this simple example to show you how trivial implementing things get with this kind of structure. Because what I'm doing is, the same prefab that we had that had just a mesh now has a script. And that script expects to do something on start and then on every frame. And all it does is it has a certain duration, looks if the duration is up, and then self-destructs, which is very fitting for an explosion. In order to achieve this, very, very shortly, this is a magic struct called delay. I'm not going to bore you too much with what is happening here. The important part is that it's just used to do math around time. It can be, it has two bounding values for like how long the delay should be, and it randomizes between the two, and then offers a bunch of functionalities for like, I can request a next delay, which sort of timestamps at that moment, and then I can ask, is this delay up? Or like how much time is remaining, how much time has elapsed since last time I requested a delay. Give me a percentage, give me a quadratic curve of the percentage, and whatever else we might figure out. I find it's useful to have these kinds of abstractions on math, especially when working with update code, because this way we can work with a very simple struct, run some simple code, and we don't have to worry about there is no state machine, there's no coroutine to do stuff with time. I just check every frame and then I'm done. Our sphere now self-destructs. On to section number 3. I promise you it's going to get more interesting pretty soon. So far we've been doing stuff that, like it models an explosion, but uses a lot of our imagination. And I think in order to move on to start like getting things actually moving on the screen, we will inevitably have to do some math. So this is what I've done in this section. I will now talk a little bit about collision checking and also presenting the information in a way that is useful for anyone doing gameplay. So if I play the game and I turn on my gizmos, I will actually maximize the screen so it's slightly better visible. I still get the same behavior, but now if I actually overlap our target dummy, you will notice, I hope it's visible, maybe I can actually zoom in on this. There are two lines that appear whenever an overlap happens. Those lines is the result of math that I'm doing under the hood that I will show off very shortly. And to describe it, essentially the vertical line is a useful way of showing a point of contact. In top down, I think that's the easiest way to show like an exact point somewhere on the floor. And the horizontal line is the direction this box would get pushed away if a force was actually applied from an epicenter of an explosion. One thing that I wanted to show off, I hope it's visible, the horizontal line gets darker depending on how far the epicenter actually is. And this is my example of how you can use this kind of doing gameplay as a bunch of lines or like debug gizmos first as a way to arrive at a point where my math is solid. Because I think testing, obviously this is going to be used for how strong the knockback is going to be. And I found in my years of practice that testing stuff like this through actual gameplay can drive you crazy very quickly. Because it's not always easy to tell what's what after staring at something happening for like a few hours. So I like to just have my very gizmos that I understand very well how they work, and then figure out the math first. And now that we have this information, we'll be able to get some things moving. But first, let's see how the code has changed. So as you can see, the AOE script, the explosion script, remains pretty straightforward. The only thing that's new is, except on top of starting some kind of a duration, we have a volume now that describes the area of effect quite literally. And we can ask the volume to do an overlap. We provide a collection or like a space where we can store our information. And then we can iterate over the entries in this space and do some drawing. And that's it. This one line of code produces our pointy lines that I've just showed off. So let's take a look at gameplay volume. This one is not as straightforward, but this is very much a case of like the complexity will inevitably end up living somewhere. In this case, the most complex things we're going to be doing with these explosions is the math that is necessary to determine, the forces, the directions. So here's where it has ended up. And what I like to do is, again, as usual, start with data. So this is a piece of data that we will be exposing for every item that is affected by an explosion, starting with a component. This is essentially a way for someone who asks for overlaps to ask for a specific, give me all the overlaps of this component, right? So if you have a hitbox or a collider or a game object or whatever else we want to hit with our volume, we can specify what that should be, and the volume will only include those components in the results. And then it's pretty straightforward. It's a position, a direction away from the epicenter, the radius of the explosion in case it's needed for math, some distances in percentages, and then a way to draw things. So whenever I have a struct that describes something in gameplay, I like to have methods that just, do my gizmos so I can test them and understand how they work. So you can see that, this is the vertical line that is just at the position of contact. And then this is the line away. And I calculate the color between red and black based on the percentage distance. At this point, if those lines are wrong, I can easily debug the math and just try things before my box starts flying all over the screen, and I stop being able to to easily understand like exactly what happened. I'm not going to bore you too much with the math. The important part is like this is like a physics query. So Unity and like this is physics because we're in 3D offers a bunch of different ways of checking like spheres, boxes, and all kinds of volumes. So I use that to just gather a bunch of things that are inside our volume. And then it's just a simple for loop. I check for the component. Again, this is the component at the top. If we have the component, we continue, we do a bunch of math, we pack it in a struct, which is going to be very useful in a second. And then we return success or fail, depending on how full the collection actually is. Going back to how we use this, right now, we actually don't make any use of the actual data, but it will become clear why it's cool in a second. Just to make sure it's clear, if we were to take a look at oh, I'm missing an S. Let's do this. Yeah. So if we were to take a pick inside of this, for every hit we go through, we can actually access a bunch of things that we calculated, right? So this is exactly the same thing that I've shown you in this struct. And we will make a good use out of it just in a second. So let's go to section number 4, where things finally start being interesting. You can see that the level now actually has walls, and that's for a good reason, because now I've taken the math that I've calculated. Oh, this is very small, but I will maximize this, and hopefully it's better visible. So I've taken all the math, and now whenever we explode, we actually affect the target dummy. And as you can very clearly see, we have the classic case of floaty physics. So before we do anything else, let's just do something about that. Quite a while ago, I have this little script that changes the gravity. Quite a while ago, I've read some article on how to fix your floaty physics that said, double your gravity. I've learned since to just quadruple it instead. So if we try it with this, it's slightly better. It's not as easy to get the box off the ground, but it is pretty sluggish. And so the other thing that I like to do, and this works in cartoony games, which is what I tend to gravitate towards, and especially do so in jams. Maybe don't do this in a realistic game. Some people might be familiar with Mario gravity. It's like in some Mario games, Mario is affected by gravity in different ways, depending on if the character is traveling upwards or downwards. Don't quote me on that, but I believe it should be double the gravity when moving downwards. So what I've done is I have on my unit, I have a script that's like rigid body custom gravity, and it allows me to do a few things. But firstly, I can double the downward gravity. Very quickly, the difference is not going to be as pronounced, but it's even harder to now get this off the ground, and it falls faster once it reaches the apex, which is good. But it's still a little bit too floaty for me. So what I like to do is also keep the traditional gravity going. So I both apply the force downwards at twice the gravity strength, and then I also apply the traditional gravity, which should produce a behavior. Let's see. Can I get it off the edge of the screen so it's visible? Yeah. It's not flying across the screen as nicely, and I don't know what the frame rate is for the thing, but we get like what we achieve with this is we can apply quite a strong force to the box, and even if it bounces upwards, it's it behaves in a dynamic way that I like. I like to be able to apply strong forces and not have things flying all over the screen. And those two things that basically multiplied the gravity a bunch of times helped achieve that. One happy accident that I've noticed is if we keep the normal gravity and then do the downward gravity scale to -1, we end up with an interesting case of no gravity. So if anyone wanted to make a space game that happens in low gravity environments, this is one way to do it that's quite trivial. And also maybe this would be quite cool to apply after an effect of some kind of a spell. So yeah, that's my 3 cents on making things non-floaty. And with that in hand, we can take a look at how the math works for the actual explosion. So maybe let's take a look at the prefab first. We have some configuration options. We always could set the duration because this is the first thing that we've done. We can set the volume, which has a radius. And now we also expose a force along a wave vector, which is the force that we apply away from the epicenter. And with this data in mind, we can take a look at how the script works. It's very, very simple, as I promised. So we take the information that we've calculated and we pack it into a game event, which is our struct that describes a very simple force impact. And since we are broadcasting a piece of information, it stands to reason to also have someone receive it. So here's our hitbox script. This script you attach to anything that needs to react to a force impact. So let's ignore this because this is for a future section. Again, 47 line of code is not that much. I hope it's not too intimidating. We have a rigid body. We subscribe to an event, and the event itself is literally, grab the direction, multiply it by force, add force to a rigid body, and we're done. That's our gameplay, and that's how we are moving from calculating the overlap to actually having a box react to it on screen. I hope it becomes apparent why I decided to go with this way of communicating things, and I hope it maybe inspires someone to also do it in this way. A very quick word on physics materials that I'm using for this. This is I don't know how well known this is. Everyone knows that who works with physics, that you probably know you can set a bunch of physics properties on how to handle collisions for dynamic bodies. One thing that I sort of notice sometimes people I work with not realize is that the bounciness, the combine, is very important. So in our case, the wall is at bounciness number 1, so you never lose any velocity when bouncing, which is very good for this presentation because I want this thing to move away from walls. And then the unit itself is at 0.3, and the combine is average of the two. So the bounciness is never what you actually explicitly set in this material unless you do a maximum or minimum. Just something to keep in mind. Okay, let's move on to section number 5, because in this section, I'm going to expose a shortcoming of what we've done so far. I've turned our target dummy into a French fry, and if I now try to apply some force to it, actually, just give me a second, because I said I will expose something, and then it worked as intended, which is the reverse of what it usually happens. Okay. So this is our explosion, the exact one that we just implemented. And as you can see, it worked for a box that had the same dimension, the same measurement in every dimension. But for a French fry, it's not that good. It applies the force at the center of its mass, and the explosion is not, it doesn't look too good. So we can probably make it a little bit better. I have my explosion 5 version 5. And again, the code hasn't really changed. The only thing we're doing is now we have another event that's called better force impact that has a bunch more information. And we pass this information from our volume overlap math. I don't think we do any math for the math, but maybe do some percentages for the fall off. But essentially, we're going to react to an explosion in a much better way. So we need quite a bit more information. We need a position, a directional strength. Force we already had. Fall off is how strong the impact is based on the distance to the epicenter. Upward bias is a cool thing that I like to do where, like a lot of explosions in games, I like them to just eject things upwards, but it doesn't always if you do it realistically, you can have an epicenter of explosion above your target, so it would push it towards the ground. So if I want an explosion that specifically launches everything in the air, I will do, I will bias it towards the up direction. And then two cool things, reset velocity if I want the explosion impact to ignore any pre-existing state, which is good for arcade games. And invert direction, if I ever want to make a singularity instead of an explosion, I can just invert the direction it applies the forces and now have it pull everything together. So let's take a look at how this is actually used in a hitbox, which I have here. Again, a very cool thing. Notice how I just added a piece of data. I have my explosion, code point like version 5 that exists along the other solution, and then I can have a hitbox. The very same script just support two different solutions by just reacting to two different pieces of data. This is again the point about this message system being very robust at refactoring and like supporting a bunch of things very easily. And things are not tangled. There is no spaghetti going on here. I can, those two impacts can coexist peacefully, and I can easily delete one or the other by just removing literally a few lines of code. So let's take a very quick look at the math here. It's not that complicated. What we do is if we need to reset velocity, we reset velocity. If we need to be biased towards up, we do spherical interpolation between up and our direction. A spherical interpolation is essentially finding a direction between two vectors and then keeping the length of the vector the same. So it literally like draws an arc. And then we apply the directional strength by just multiplying each component by the component of the strength in corresponding axis. I see some messages in chat popping up. I will take a look after I'm done with this line of thought. Invert the direction, calculate the impulse again and factor in the fall off, and then add force at position. This is something that physics already features. So we just need to pass it the point that we've calculated earlier, and we're done. Our explosion is now much improved. So let's take a look. As you can see, it's like if we wanted to be very picky, it's not ideal, but it very much is now directional. I can turn around the thing by just angling my explosion, which is nice. And to maybe showcase it a little bit better, I have my scene 5B, which features a bunch of French fries. And this hopefully will be satisfying. I can now, I guess are there French fries? Maybe there are dominoes. But anyway, I can now scatter them together, like scatter them away from the center of my sphere, which again, hopefully moves us a little bit closer to having, a boom on the screen. Okay, I think that's it for the section. I'm going to take a very quick look at the chat. Mario Gravity. I think the Flappy Bird definitely use some kind of a custom, like it's people like to rag on that game, but it has a certain intentional way it's mechanical about gravity. And yes, I think it's like generally any game I am making, if it's cartoony, I will make crimes against realism for whatever purpose I am after as a game designer. Okay, section number 6 is the section where we move away from our sphere and towards an actual thing that is, visual and also has a sound and has a feel. So, is this the right scene? No, it's not. This one. Please excuse my subpar VFX work. This could be made much better with a shader and an actual artist. But the plus side is, it sort of looks like an explosion. You can put it together without any assets. I think the cloud is like a very simple mesh. I now realize I haven't shared audio, and I don't know how to do that. So I'm not going to faff about with the controls, but it also includes VFX, which is very important. I'm really sorry for not including it, but especially working with explosives. It's a very important thing to have. So there are a few things happening. I am playing a VFX, which is a bunch of particle systems. I am playing a random audio clip that you cannot hear. Again, sorry. And then the screen is shaking very subtly. However, the implementation is trauma-based, and the trauma adds up. So the more trauma, the more the screen shakes. And if I do a bunch of explosions in a row, you will actually notice that it does add up. Which I find very cool, and it's doesn't seem to be as popular in video games that I play. So I really want to make like one day make a game that features this prominently, and it's cool. And it's also featured in the talk that I've linked. I have linked in my slides. So yeah, hopefully that's a little bit better. I can maybe make this better very quickly by doing something like this. Yeah, that feels better. Usually, like with like dynamic things like that, sometimes you double the force or the speed or the impact, and it's just nicer. So let's take a look at how this is done. I realize I've been going for a very long time, so I'll try to make it quick. The VFX I like to make a case for just having VFX together. This is also not a novel idea, but I am very much a proponent of it. So I literally have a script. Maybe I can show you from the inspector point of view that says VFX. It's a prefab, and I have a screen shake. I can turn it on and off. I can set a trauma, and I can still tell it to decay faster or slower. I can do a screen freeze, which is a cool technique that's sometimes used with like more arcadey games, where you literally freeze the game before something important is happening to like have a little bit of anticipation. This is very much like a fine spice type of feedback. I would always like 0.1 is probably way too much. And then if we take a peek inside of this prefab, it literally has a bunch of particle systems that I can play. Oh, and I'm very, very far away. So let's do this. Still far away. Oh yeah, now we can see it. Right, so there is a bunch of particle systems, and right along with them are the SFX clips, which is a script that plays a random clip out of the selection of the three and another source. And that's it. That's our, this is the entire explosion described in one asset. And the cool thing about the script is that it sort of discovers this all automatically, right? I just grab all the sources or the particle systems that in it, and then I trigger everything to play, right? I do like for screen shake, I do screen shake. For screen freeze, I tell some stuff to screen freeze. This is a very naive implementation, by the way. This is very much like a quick thing, but it works for the purpose of the demo. And then the cool stuff in update is I go through the list of things that I triggered, like all the sources that are playing and all the particle systems that are playing, and I just early return whenever something is still busy. And after that, if nothing reports doing anything, I can safely despawn self-destruct. And this turns this VFX blast into a very nice fire and forget type of a thing. So if I take a look at AoE section 6, I've added a reference to a, to a prefab, and the way it's used is literally I instantiate, or like as the term goes or the phrase goes, I fire and then forget. I don't have to worry about it. It's going to self-destruct when it's done, which is very nice, and it makes it very easy to just feature visual effects or like audio effects anywhere in your game. And it also should ideally make it easy for any artist to just go in the prefab, add your effects, and they are going to play. Just you don't need to worry about hooking them up, dragging them the references anywhere, triggering any events by enums, by string, by whatever. Just just put it together, and then what you see is what you get, or maybe what you hear also. So that's the VFX part. Very, very quickly, just to keep the theme of taking a look at how things are structured. I had to break my promise. We do have something that does resemble a little bit of a singleton, but it's very limited. So the thing about the screen shake camera is that if we are a VFX, we have no idea who handles screen shakes. So, but we still want to just send a struct that describes our screen shake to someone and then have them do it. So the way I achieve this is by having this helper global events that all it does, it exposes a static version of send message, and then it can be initialized by any client to actually exist in the game. And of course, we do this in our center of operation, which is the game. So if I now unfurl the section number 6, we have an instance of global events. And what we do is we pass ourselves our own event handler that lives on the game, as the event bus that should receive all the global events. It still sucks that it's static. I couldn't figure out a way to do this quickly for this presentation. But what is good is that if we take a look at VFX, we still don't know, like we are still not concrete, right? We still send a message. We don't know who receives it, how they intend to use it. We can easily just remove the camera screen shake script, and nothing is going to break in our game. And also, if anyone will be curious and type global events dot, they don't really get that many options. So it's literally impossible to misuse this static access for any other purpose than to send a message to the game, which is good. Okay, just one more section to wrap things up and set me up for my final point. I really wanted to inspire using explosions creatively, and what we've created here, for different purposes, and take advantage of modularity. So I wanted to implement something very simple. In this case, it's like a bit of you can think of it as an explosive barrel that has a delay, or like a grenade maybe, and that's triggered by any damage. So I've written this simple script. It is a little bit longer, on the longer side, at 45 lines of code, but hopefully nothing too drastic. So it has a delay, so we explode after some delay. It has a reference to any explosion we might want. We can set it up on the prefab, and it has some warning VFX, which also leverages the modular VFX way of doing things we have set up. So it subscribes to the the force impact, because why not? We already have it set up. And then whenever it actually is hit by something, we start the delay, we spawn the warning, which sort of tells the user, hey, I'm about to explode. And then once the delay is up, we self-destruct, we instantiate the explosion, we're done. So the logic, again, should be pretty straightforward. And if I show you how it works, I can now do this. This is almost gameplay, right? Like I could we don't have any characters and any goals, but I could propagate, I could set up a level with this and then have the character intentionally or unintentionally enter explosive gameplay situations with this. So I really wanted to show that we have a cool system that we could now leverage in different kinds of games. And just for a final presentation, I'm going to enable this. Oh, there is a bunch of things. I just really wanted to do that. So like one thing that I'm sort of known for is like whenever I do stuff with physics, like if you already we went through quite a through quite a hustle to get things going. So I think we should make a lot of use of it. Like modern computers are strong, so if you have physics and you have cool explosions, make sure to have a bunch of objects. Maybe not at this scale, but imagine a bar fight with a bunch of props. If there are a bunch of props that are exploding and moving around, then you have a very dynamic scene. Also to make a reference to the speaker, to D, who was talking about movies in the presentation before me. So yeah, that's my demo. I did promise to hopefully inspire some creative use of what we've done here. So I just want to leave you with a few examples. Obviously, we've done a literal explosion, but this AoE could be used for all kinds of purposes. Some that come to mind, I did not grab the screenshots, I have to admit. But the next time, the Elden Ring currently is very popular. Next time you execute someone and there's a bunch of enemies around, notice how they all get staggered away from you so they don't interrupt right after you're out of the animation. I don't know if they implemented it in this exact way, probably not. But we could very much have an invisible explosion and just apply a stagger with a simple event and have people give respect to such a happening. I've also worked on a game where I had the barbarian shout implemented in this way, where it was literally just a sphere around the character that staggered enemies away. Or maybe next time you play Smash and do a bunch of attacks and then look up the hurt boxes, they should look pretty similar to how we have set up the hitboxes and the volumes. And you can make a case for like almost every Smash attack is like some form of AoE. So this actually, this like small piece of technology that we've put together through those 7 sections and this bunch of hopefully digestible scripts. I hope you believe me when I say that it's actually quite powerful. And I really like to do this, especially in game jams, because you can usually model most of like damaging gameplay, or like maybe not damaging, maybe healing gameplay as well, with area of effect. So I think that's my talk. And again, I am on Discord. If anyone actually plays around with the code, feel free to DM me. I will accept any questions, any critique, any comments very happily. And thank you for having me.